Hi guys! So in this video, I'll show you how to create a 3D crystal structure, IV solid. So I choose sodium chloride or NaCl as a model because it's one of the crystal that I usually see every day. So before we go to the construction of the crystal model, let's look at first what really is a sodium chloride. Sodium chloride is best thought of a face-centered cubic with an array of anions with an interpenetrating FCC cation lattice or vice versa. The cell looks the same whether you start with anions or cations on the corners. Each ion is 6 coordinate and has a local octahedral geometry. The smaller ions are the sodium ions that has an atomic radius of 102 picometers, and the larger ions are the chlorine ions with an atomic radius of 181 picometers. Since sodium chloride are 1-to-1 ratio as a compound, the coordination number of sodium and chlorine are equal. However, the structure of this molecule allows their position to be switched since the coordination numbers are equivalent. The unit cell of sodium chloride consists of sodium ions and chlorine ions. There are 4 types of sites. These are the unique central position, face site, edge site, and corner site, which are used to determine the number of sodium ions and chlorine ions in the unit cell of a sodium chloride. When counting the number of ions, a corner site would be shared by 7 other unit cells. Therefore, one corner would be 1/8 of an ion. A similar occurrence happened with the face site and the edge site. For a face site, it is shared by one other unit cell, and for an edge site, the ion is shared by 3 other unit cells. The sodium chloride is a face-centered cubic unit cell that has 4 cations and 4 anions. This can be shown by counting the number of ions and multiplying them in relation to their position. NaCl is an ionic compound that occurs naturally as white crystals. It is extracted from the mineral form halite or evaporation of seawater. The structure of an NaCl is formed by repeating the face-centered cubic unit cell and has a packing efficiency of 74%. It has 1-to-1 stoichiometry ratio of sodium and chlorine with a molar mass of 58.4 grams per mole, and the sodium chloride generally crystallizes in a cubic closed pack array of chlorine ions with sodium ions in the octahedral holes between the planes of the chlorine ions. Sodium chloride, a white crystalline solid, contains a density of 2.165 grams per milliliters, a melting point of 801 Celsius, and a boiling point of about 1413 Celsius. It is also available as aqueous solutions with different concentration, which are known as saline solution. Sodium chloride is a readily soluble compound in water and other polar solvent, and it is also a stable solid. It decomposes only at high temperature to produce toxic fumes of disodium oxide and hydrochloric acid. So what are the uses of sodium chloride? Sodium chloride is a well-known table salt and is widely used in the food industry for flavoring and preservation. It is also used to produce various essential chemicals including sodium hydroxide, baking soda, sodium carbonate, hydrochloric acid, and more. It also has application in the textile industries, oil refineries, paper and pulp industry, fire retardants, road construction, and the rubber industry. In the soda ash industry, it is used to produce sodium carbonate through the Solvay process. The compound is also used in cleaners like shampoo, toothpaste, and even in water softeners. These saline solutions are also used for various medical purposes. In order to make the 3D crystal model, we need these materials to start. First, we have the glue, water, papers, glue gun and glue stick, and some watercolor and a brush. The first step in making the paperboard mache is to mix the glue with water. Next step is to cut the paper into smaller pieces and soak them in the water. Make sure to soak the paper properly and form them into ball shape. So now that we have the balls for the cubic lattice model, all we have to do is just wait for them to dry up and we can start assembling them. Creating the paper mache ball was the hardest and most time-consuming step for this activity for me because I needed to create the balls from scratch from the papers to create the paper mache balls, and I needed to create two sizes of ball, one for the chlorine one for the sodium. And before I can proceed to the next step, I needed to wait 2 days for it to dry and paint it. So I actually decided to paint the balls with watercolor so that it has some color to it. painting the paper mache ball was a pretty straightforward step, and I just needed to wait around 2 hours for it to dry up before I can start assembling the 3D model. Now that I have colored the balls, now I'm going to assemble the cubic lattice model. Assembling the 3D model was a bit hard for me because the glue stick won't stick that much to the paper mache. So I needed to attach one ball at a time and wait for the glue to dry up before I can start adding more balls to the model. Creating the 3D model was a new experience for me. Also, it was a bit tiring because I needed to wait a lot for the paper mache to dry up. I also learned that the paper mache and glue stick don't work well together. The glue stick won't stick to the paper mache, so I needed them to dry up first before I can start adding more. I definitely learned a lot, especially when it comes to the structure of solids, especially the crystals. Performing this activity also gave me a sense of reality, especially in these times where everything is pretty much virtual. So I definitely had fun doing it. So that's it for this video, guys. Bye bye.